Coming up on this episode of DevelopSec Live, we take a look at some of the changes in the new OWASP Top 10 for 2017, look at Google Multi-Factor, Tinder's privacy, and a vulnerability in Electron. Tackling the challenge to integrate security into the development process? Looking for insights, answers, and practical solutions to avoid getting overwhelmed? Welcome to the DevelopSec Live, where our focus is your success in securing and improving development processes. And here's your host, James Jardine. Hey everyone, welcome to this episode of DevelopSec Live, something I'm trying new rather than just doing the podcast where we listen through MP3. Trying something a little bit different, go a little live, see if we get some traction with that. Trying to share application security insights with everybody out there. So hopefully you enjoy this. Feel free, send me information back, james@developsec.com, or hit me up at DevelopSec on Twitter. Send me your feedback. Let me know what you think. We're doing a couple different things. We're going to talk a little bit about OWASP and the new OWASP 2017. Not going to dive deep into what we have in there, but we're going to do some comparisons to the 2013 list and the 2017 list. Then we're going to cover a little bit of news, a couple news stories that are out there. I try to cover news in a way that is productive, right? So we're talking about, hey, what happened and how can we learn from that? Anybody that follows knows I do a lot of lesson learned type things. So that's what we're doing with the news. Let's look at it. Let's be real about it. And let's see what we can take away from that news so that way we can bring it back to our organizations, bring it back to our personal lives, and see if that can help better us from a security perspective. And then at the very end today, we actually have a short little demo. In the news segment, we're going to talk about Google and two-factor authentication. So I have a quick little demo walkthrough that walks through setting up two-factor authentication on Google, so for your Gmail and those type of things. So to start off, I want to talk a little bit about OWASP Top 10. Everybody has heard of OWASP Top 10. I mean, if you're an AppSec, you've definitely heard of OWASP Top 10. It's one of those, not really a standard, but it's one of the most recognized lists out there of security risks. So if you don't know what OWASP is, it's the Open Web Application Security Project. They've been around for a long time. And in that, every 3 years or so, they went a little long this time, they produce a top 10 risks list. And a lot of places reference this. You got PCI, you got all different things that reference the OWASP Top 10. And it's kind of that baseline, right, that everybody should know. If you're in application security, you should know the OWASP Top 10. Now, that's not to say there's not a whole bunch of other vulnerabilities that are still a risk here, because there are. This is just kind of, hey, as an industry, they've picked kind of the 10 top risks that we see, and it's an awareness tool, right? It's a way to get people involved. It's a way to, at least put something out there and say, hey, yeah, we've got 100 vulnerabilities that we could cover, but here's 10 that you can focus on to get started, and these are the top risks. So, we commonly see things like SQL injection, cross-site scripting, terms we hear all the time, we see all the time, and that's what they're doing, right? They're calling attention to those. And the last list we had was from 2013. Now we've got a list in 2017 with some changes, and we'll walk through a little bit of what those changes are. Not going too deep into each one, because in later episodes, we'll actually start talking about each kind of item from the OWASP Top 10, so we understand what it is and how we can start protecting ourselves from it, right? And start to understand the risk. Like, what does that actually mean? So going back, right, OWASP Top 10, it's important. We see it everywhere. I see it all the time on job recs, right? People looking for application security people all the time. They say, hey, we want, foundational knowledge of OWASP Top 10. I see it in marketing. It's all over the place in marketing. Hey, our security is up to OWASP Top 10, SANS Top 25, right? I mean, we use it everywhere. So it's important for us to understand what it is, what its effectiveness is, and how we can take that and consume it internally to make sure that we're doing what we need to do to help protect our applications. Because again, there's a lot of vulnerabilities out there. And I think especially this year, the way the changes went, you might find that you're looking at other vulnerabilities more than you're looking at some of the OWASP Top 10, just because some of them, I feel this year, are less in tune for what a lot of people are dealing with. So the way they did some of the changes, taking certain items off, which we'll look at, because frameworks are starting to take control of those a little bit better. I mean, that's one of the great things about technology right now is that we have in development new frameworks coming out, and we're finding ways to solve a lot of these problems, or at least reduce them. The downside is that's only if you're using the latest technologies. If you're still dealing with legacy applications, if you're still building on older stacks, right, they don't have these built-in capabilities. So of course, that can be a problem, and people have a hard time, consuming that information to then put it out there. So let's take a look at what the top 10 looks like real quick here. We'll take a look at it and we'll see what the 2013 top 10 look like. So here we can see we've got pretty simple. I mean, this is from 2013, so this has been around for quite a while. And with that, obviously, a lot of people have a lot of knowledge about this, right? We know about injection, where we talk about SQL injection, LDAP injection, XML injection, right? There's all kinds of injection type attacks that we have out there. Usually listed as number one, because usually it's pretty easy to pull off, and two, because it has a high risk to it, because if I can manipulate SQL injection and get into your database, that gives me potentially direct access to all your data, and that's where people are concerned, right? We're afraid of our data being attacked. Of course, with some of these, especially OS command injection, SQL injection, I can potentially run commands on your system. So that causes a big problem. We've got broken authentication, session management, obviously a big problem if I don't have to authenticate to your systems. Cross-site scripting, one of the most known vulnerabilities, although often I find one of the most misunderstood vulnerabilities out there. So that's on there. I don't know if that'll ever come off, even though we do have a lot of advancements in a lot of the frameworks. A lot of the view engines now do a much better job of reducing cross-site scripting flaws, but we still see them all over the place. Even with apps that are doing these new frameworks, a lot of times we're still finding cross-site scripting flaws. So they're still out there. Insecure direct object reference. Again, this is a common one. It's an old one. It's simply manipulating integer values on query strings or in input parameters to then increment them or decrement them and view other accounts or access data you shouldn't be able to access. Security misconfiguration, sensitive data exposure, right? You know what these are. Cross-site request forgery. We've had a good list out there for quite a while. Well, now we've got a new list that came out finally in 2017. The 2017 list. We expected it in 2016, but with all the data that's coming in, initially there was thought that there wasn't much change going on. So it kind of got slowed up. Now we've got it coming out and we've got the release of it. And here we can see a kind of comparison between 2013 and 2017. Not a lot of changes, but there's a few changes out there that we might want to take a look at, right? So thinking about, we still have injection, right? I mean, like I said, that's not going to go away anytime soon, right? Broken authentication, sensitive data exposure. Sensitive data exposure actually moved up in the list because we do see a lot of sensitive data being sent back down to the client, not necessarily meaning things like our response headers that, they're sensitive, but usually it's the type of server you're running or some other information like that that's not technically too sensitive compared to sensitive data like, hey, I'm returning back a full credit card number, or I'm returning back, specific health information or account information that maybe we don't need to return back down. We have XML external entities, right? That's new this year within our system. And I'll talk about that in just a second. Right, we have broken access control, which actually combined some items. Still have security misconfiguration. Cross-site scripting has actually dropped down on the list. I don't know if that necessarily means that the risk has changed. I don't really follow how they want to put things in order because cross-site scripting still has a pretty good risk to it. We see insecure deserialization now as a new item added in. Using components with known vulnerabilities, that was from last time, so that was in 2013 as well. Just because we have so much software that relies on third-party components, And what happens when those are vulnerable, right? We have to have a way to be able to understand those. So that's an existing one that's still out there. I don't see that one going away anytime soon because our reliance on third-party components isn't going to change anytime soon, I don't think. So, that's something where we need to think about, what are we doing with these certain items? And then we have insufficient logging and monitoring, which is a new one as well. So let's take a look and let's talk about the different items and actually see a comparison and break down how they go. So let's go back to 2013. Things we saw drop off the list, sort of. Insecure direct object reference and missing function level access control. We combined those two together to form the new broken access control within the 2017 list. So instead of having two slots for somewhat the same thing, I mean, insecure direct object reference is a lack of access control, right? I mean, I'm able to change a number and I'm able to view another account that's not my account. So that's where we're seeing a big difference there, is that they're really not that different. So let's combine the two and we'll just make broken access control. And, it'll give us room to add some more stuff into this list. So we combine those two together, but there's still I'm not checking authorization, right? Direct object reference, I'm not checking authorization. Yes, you can use reference maps, right, to check it. So you're not technically checking authorization, right? We're still checking it. We're just using a different way. But the root cause is I'm not checking the authorization that the user has access to certain values. So A8, cross-site request forgery, we saw deleted off. So no longer on the OWASP top 10 is cross-site request forgery. I find this interesting because I still find cross-site request forgery in most applications I test. It's rare not to find it someplace. One of the reasons, rumor tells me, is that it was pulled off because a lot of the frameworks now have built-in capabilities to help protect against cross-site request forgery. And as I said earlier, that's true. We are seeing a lot more frameworks come out where they have CSRF protection built in automatically. You don't have to do a lot with it. But even on some of those systems, we're still seeing these kind of one-off, hey, there's cross-site request forgery there. Or a lot of legacy systems, especially when these big business organizations, you get these small tech startups, it's easy for them to start using the latest and greatest versions of technology. You go back and you find all these big Fortune 500 companies that are still running on old technology. They have a much harder time of being able to shift and bring up that new technology, right? So that's very difficult. And so you still have these vulnerabilities out there. And cross-site request forgery, depending on what it's on, can be pretty serious. I always look for it in places like, changing your email address in your profile. Right? I love cross-site request forgery and a change of email address, because if I can get you to change your email address to mine, then I can do a password reset to my email instead of to your email, right? Compare that to cross-site request forgery on some benign page that doesn't really do a lot, not that big a deal, right? Which highlights an important point, that when we look at security, it's all about the context that it's in. What can I do with that? Now, what's the risk level? Because not all cross-site request forgeries are created equal. Not all SQL injections are created equal, right? Depends on where they are. Depends on what they have access to. What are you doing in the back end, right? We need to do this analysis to be able to understand that. So cross-site request forgery is off, but I caution anybody that thinks, hey, I shouldn't continue looking for this. Keep looking for it, right? Remember, this list is just a kind of foundational list to get people going on AppSec. It's not the end-all, be-all. Go out and check out the OWASP. They have the testing guide that's available. Look in there and see the things they're covering, right? Again, top 10 is just a list to get you started, but don't stop there. The other one that got deleted off in 2013 is A10, which was unvalidated redirects and forwards. I always like this one too. A lot of people rank this as low because, oh, well, you can just redirect me to another URL. That's great. But I use it all the time. When I do client demos, I show them using unvalid redirects, especially on the login screen, right? Where, how you go out to a website and it's got that, oh, here's the login page, question mark, return URL equals, And then, it sends you to the URL that you were trying to get to because the site's trying to help you out. You tried to go to your account page, you're not authenticated, redirects you to log in, but says, hey, I'll send you back to the account page. That's where you're trying to go. So it puts it up in the URL, and then when you successfully log in, it sends you over to your account page. Well, it's so easy to set up a phishing page to be able to try to attempt to steal credentials using that if you're allowing redirection outside of your current site. So if I can go take that and say, look, if I can send anybody a URL to your login screen and I put my own malicious site as the return URL, well, then I redirect out to my site, which looks exactly like your login page. The user successfully logs in to your site, but gets redirected to my page where I prompt the error message that your username or password was incorrect. They think they mistyped a password. They retype it, submit it to me, and then I redirect them back to their original site where they're already authenticated. And I'll be honest, I show this to a lot of people, and I ask them as I'm walking through this, do you notice anything wrong? And very few people actually look at the URL, right? Because if the page looks the same, it's visually the same, I'm not going to think anything of it. I'm not checking the URL of every page I visit to make sure, right? I went to the site I knew I was going to. I was actually at that site, yet I was able to get redirected to another site. But because it looked the same, there was nothing that threw me off. I just thought maybe I mistyped my password, right? And so it's so easy to do that. And it's rare to find people that'll check that when they mistype their password. Hey, are you still on the right site to re-enter your password, the site you meant to go to in the first place? So that one's still, a lot of places list it as low. I find it sort of high in those cases. Now, it's not the same everywhere, but at least on a login form, that's still kind of high. And I still push people, look, find those redirect issues because those can be used, especially if things that can be used in phishing type attacks, right? I can send you that link, you click on it, you log in, right? That's how I start it. People fall for phishing all the time. So we got to be real careful around that. So that was the 2013 list, some of the changes that we saw there. Now looking at 2017, right, as I mentioned, we now have XML external entities as part of our list. Now, this one's kind of interesting to me. I don't find it very often, to be honest, because I don't see a lot of applications that are using XML being passed from client to server. I do see this a little bit more when I look at static analysis results. So, for example, a lot of times where I see this vulnerability being flagged is where the developers are taking information from a model and then they're, serializing that down to like XML to store it in the database. And then they go take that data back out, they deserialize it, or they parse that XML. And then at that point, when they go read that XML back in, obviously, the XML parser is not checking the external entity. So if there's an entity in there, then we could actually execute and potentially steal information or run some commands. But I don't see it very often straight down from the client. Now, that doesn't mean it doesn't exist. Obviously, people see this, and that's why it's on the list. But I don't see it as often. And it's one of those things that, just like from 2013, you have to look at your system and understand, hey, what am I using here? Does XML external entities, is that something that's a problem for me? And then if it is, if you're dealing with XML, going out and finding out, hey, how can I go ahead and resolve this? And I did a lot of write-up on my site out at jardinsoftware.net, talking about for .NET specifically, Microsoft.NET, how to handle XML external entities within the .NET framework, depending on the different objects that you're using. Right? So with .NET, one of the easy ways to do this is just tell the parser, hey, I don't want you to handle XML entities. So if there's an entity there, either break or just ignore it. And unfortunately, in the older versions, by default, it would parse it. Newer versions, it's actually changing, right? And again, this is the great thing about newer technologies is, as we start going through, they start changing those defaults and say, oh, you know what? XML external entity is a problem. So rather than just go ahead and leave it to default to run, I'm going to default it to break. And then if somebody wants to actually parse these, which is a rare occurrence, then they can go in and set it to parse it, right? And then hopefully they're using whitelisting or some other feature to be able to limit that down. But for most of these situations, right, it's going into that parser and making sure it's configured properly so that it's not going to allow those entity calls to be able to reach out to your system and pull data, right? Stealing Etsy password, for example, being able to read file system files out there. That's what we're looking to try to protect against. But again, we just want to make sure, hey, are we using XML in our system anywhere? And it's a deal with just understanding what are we doing in our app, right? And understanding our app to know, is this a problem? If you're on an AppSec team, talking with developers and understanding, hey, what are you guys using? What technologies do you use? These are things we need to understand so we can better understand, hey, what are the concerns that we have for our app? As I mentioned, broken access control, that was just a combination of two. So it's not really a change. It's just the fact that instead of being listed as two different things, it's one, but it still covers insecure direct object reference, missing functionality level access controls. Those are still covered under that. And then another new one we have, insecure deserialization. Again, honestly, I don't see this very often in the apps that I'm testing, but obviously people feel that this is a big concern. The downside is that deserialization attacks can be pretty serious if you find where they are and you can pull them off, right? But what's happening is you've got serialized data that you're sending back up to the server, and when it gets deserialized, right, the code inside then could get executed. And if it's not handled properly, that execution could run other code, obviously in the context of the current application, which can be a big problem. So again, on that one, you just want to make sure, hey, are we using any type of serialization, deserialization back and forth between client and server, or between two different server pieces? Maybe you're calling out to other applications. How do we handle that data coming back and forth, right? Serialization is common. The question is, how are you handling that serialization to make sure that when you deserialize, you're not running stuff that you're not expecting to run? And then the final change, the new addition on 2017, is the insufficient logging and monitoring, which is important, right? I mean, obviously, if we're not logging in our systems, then when something happens, how do we know what happened, right? We don't, because we're not doing any logging. And logging can be difficult because a lot of people, they don't know what's a log. Every time you talk about logging, it's, oh, well, you need to log this and this, and you got a full page of this is all the stuff we need to log. And it's like, I'm not logging all that stuff. In addition, where are you logging it to? Who's monitoring those logs to be able to see what's going on? And in my experience, most logging and monitoring is usually done via an email system where troubleshooting events, right? An exception occurred in the app. Let me email that to some mailbox, and then one of the devs will log in every day and they'll look through the logs to see what's breaking the application, right? It's not a security measure. It's a, hey, let's just make sure the app's running as we expect it to be running. And that can be kind of difficult and tricky because, you're not logging all the stuff you should be logging, all right? Yeah, you're logging the exceptions, which is good, right? We want to know when things are causing exceptions. Some attacks cause exceptions, right? So we want to make sure that as we're doing things, we're picking those things up, but not everything causes exceptions, right? I mean, when I do insufficient access control, that may not necessarily cause exceptions out there, but I'm trying to access data I shouldn't be able to access, right? So we want to make sure that as we're going through and we're running our applications, we're logging the right data, that we're logging unsuccessful and successful login attempts. We're logging unsuccessful attempts to access data that doesn't belong to us, right? There's a lot of stuff we need to log. And we'll start digging into that as we start covering more of the OWASP Top 10 individual items, not just here, which is just kind of an overview of the OWASP Top 10, but we'll actually cover a lot of those individual items and more about what we should be looking for to help better our applications. And we need to think about monitoring, right? How do we monitor that? That's great, we log all this data, but do you notice when somebody locks out a whole ton of accounts? Do you notice when the same account gets locked out? Or, a ton of requests come in and there's a whole bunch of failed login requests across the application within a given time period. These are things that we should be able to start detecting. And it may be something that we need to reach out to, our different divisions, right? Talking with the network team, the security teams, who's dealing with network monitoring, right? Do we have a SOC of some sort that monitors all the traffic and all the events that are occurring? And then they take that and bring it out and they handle it, right? I mean, so they can quickly pick up, hey, these are the events that are of concern. We need to get something out here to do something with this. So OWASP is important, right? I mean, it's a great tool that's out there. There's been lots of back and forth, lots of debate over it with this latest release. First draft of it got rejected. There was some issues there, but in general, the OWASP Top 10 is good. It's a good starting place. It's good to know. It's a good just to kind of get your feet wet and say, hey, we're starting to do something, right? It's that building block to get us going. But just keep in mind, OWASP has a whole bunch of other tools like the testing guide, right? They've got all kinds of guidelines, all these different things that you can use. Pretty cool tools out there when we talk about known vulnerable components that, hey, we've got these tools, let's go ahead and get these going so we can go out and scan for our systems to say, hey, what components are we even using? And then we can start tracking those to see if they have known vulnerabilities or not. So don't leave the OWASP Top 10 out there, right? We want to use it. Things change with it. We need to stay up to date with that. But don't go ahead and change everything you're doing just because the OWASP Top 10 has changed. Make sure that what you're doing is working. It's working for you. It's working for what you're doing in your organization and not all these other different organizations, right? Remember, it's a general list. It's there where across the board, we've scanned thousands of applications and here's the top things we're seeing. Doesn't mean they're all in your app. All right. So make sure you're checking that. Do the assessment, do the analysis of your systems and find out what's important to you. Trying to meet OWASP Top 10 just because it's what everybody has as a benchmark, but also making sure that you're focused on the high risks that you've defined internally because they may be different than what exists out on the OWASP Top 10. So thanks for watching this portion of it. We're going to start the news segment next. And then after that, again, as I mentioned, we'll do the demo of setting up the Gmail authentication, two-factor authentication to get your systems going. Again, you can always reach out at James@DevelopSec or just at DevelopSec on Twitter. So thanks again for listening. Hey everyone, welcome to this episode of the DevelopSec newscast. Today we're going to talk about news that's interesting, but also that helps us understand how we can do better on our own applications to protect us going forward. So the first news story we want to talk about is Google two-factor authentication. It comes out in the Usenix Enigma 2018 presentation that less than 10% of Gmail or Google users actually use multi-factor authentication. Now we know multi-factor authentication is important because it helps protect us from attacks where we've had credentials stolen from other applications, right? We're reusing those credentials across different applications. And this causes a problem because I can then take those credentials and because we reuse the same email address or logins across applications, then go log into your application in another account. So we use a second factor or multi-factor authentication. So that way, when you get the username and password and enter it correctly, then you're prompted for another factor, right? And in most cases, it's an SMS token that's sent to you. You can use Google Authenticator. There's a bunch of different authenticator apps that are available to help protect you. But it's important to make sure that on all the applications that we have, if we have multi-factor available, then we should be enabling this. And we have a demo coming up after the newscast that shows how to go into Google and enable two-factor authentication to help protect your account. But we're going to make sure we're doing this, and a lot of people aren't. So from organization standpoint, we need to make sure that if we're using things like Gmail, Outlook, all these different offerings that are there, that if they have two-factor, we're enforcing that. Go in and set that up for your organization. If you're a regular user, then you want to make sure that you're coming through and setting that up for each account that you have, but that's going to really help protect you. Oftentimes we think that mail isn't that important But we also use mail for a lot of two-factor authentication, right? You might get mailed a code and you need to get into that, or you get recovery options. I forgot my password. I get a link to be able to recover my account. That comes through email. So we really want to make sure, especially with email, that we're protecting our accounts to make sure that somebody can't gain access to any of our other applications. So keep that in mind when you're looking at the applications that you have and the ways that you can protect that. Most applications today have two-factor capabilities. You just have to go in and enable those. Now, the next story we have, Tinder. Everybody loves Tinder. So if you're using it, what are the privacy concerns that may be there? And it was just an article that came out talking about how they encrypt some of their communications between the mobile app on your iPhone or Android device and the server. So when we think about privacy in that, we're talking about transportation privacy, right? The data between your device flowing all the way up to the back-end server. So as you're sitting there flipping through images and doing stuff in the application, anybody on the wire can't see what's actually happening. Well, in this case, what was found is most of the data is actually encrypted, right? It's protected in transit. So who you are, all your account data, all that stuff is actually protected. But it was found that the photos that you're seeing, that you're swiping left and swiping right to, is actually not protected. So those photos are coming across in clear text. Somebody sitting in the same coffee shop on the same network can actually see those photos going back and forth across the wire. Now, what's interesting about this is that while we can see the photos, we really don't know who they're associated with. So you're really not losing who you are. And these photos, I mean, have been, willfully and voluntarily uploaded so that way you can see them, right? They're not secret photos, but it's an indication that, hey, we've got some piece that wasn't being encrypted. And when we look at protecting our data, we look at thinking, hey, we want to encrypt all the data going back and forth, not just certain pieces. And so being able to see the photos may not seem like that big of a deal. Okay, yeah, we can see photos, but we could see those anyway. Log into Tinder, you can go see them. So it's not that big of a deal that we can see that, but there's other issues with being able to intercept traffic going back and forth, being able to maybe manipulate that traffic. So if I could change those photos that are coming down, what could I do with that? That could be something of a concern. Now, in addition, with the encrypted traffic, they also found that the encrypted traffic was, predictable. So whether you swiped right or whether you swiped left, you could tell just by even looking at the encrypted traffic whether you swiped right or whether you swiped left. So now I've got a photo and I've got whether you liked it or rejected it. I can determine that. I still don't know who, so I'd still have to be looking at your shoulder to see that, oh, you're the one looking at these photos. But I'm getting a little bit more information. Now, the encrypted piece is interesting because at least we're encrypting it. Now, it was recommended that they actually pad the encryption so that way you can't tell. But to be fair, if you were to just to encrypt the photo, then you still wouldn't know which photo is being liked and which one's not being liked. So there's lots of things you could do here, but from an organizational standpoint and a development standpoint, when you're looking at your apps and you're thinking about privacy, look to make sure that you're encrypting everything that's going back and forth, whether it's photos, even if it's something that doesn't seem important. We want to make sure that we are encrypting that data so that way it is protected going back and forth. Even if it's not sensitive, we don't want people to be able to manipulate that data to be able to change and maybe affect the end users that we have using these systems. So just keep that in mind as you're using these systems out there. Now, another interesting thing out there is Electron. I don't know how many people have used Electron or seen Electron. You've probably used it. You may not have known it. Electron's a popular programming framework to create cross-platform applications that work, on anything basically, with the same code base. It uses JavaScript, it uses CSS, HTML, right? It's using kind of those client-side technologies to build these cross-platform applications. If you use things like Skype, Slack, right? A bunch of these all use Electron in the background. That's how they're built, so that way they work across the platform. Well, it was identified that if you register your own protocol handler, that there could be a vulnerability that could be abused by an attacker. So when I say own protocol handler, right? If you're doing something where if I type Slack : / or my app : / right? These are ways that from other applications I can call into my application. So I can send somebody a link, or I can put a link on my web page that says, hey, if you want to go to my Slack channel, click this link, and it'll start with Slack : / and then the link to my channel. And then when you click it, it'll actually open up the Slack application and bring you to it. Same thing when you do with Skype, right? You can send Skype numbers and you click it and it'll open it up in Skype. So there's lots of cool things you can do with this, but apparently there was a vulnerability found with this that if you're using that type of technology, then you could be at risk. So the recommendation there is if you're using Electron for your frameworks to build your applications, make sure you're going out and grabbing the latest version, right? We always want to make sure we're keeping up to date on the software we use. Even these third-party pieces, we got to make sure that we're keeping those up to date. So this is great. They come out and say, hey, we've got this. You need to update. If you're somebody that's building these apps, you need to go out and make sure you update. Now, this was something that was only affecting Windows operating systems. So apps running on other operating systems weren't affected by this, just ones running on Windows. The latest report is that Slack, Skype, not vulnerable to this if you're running the latest version. So if you're not, make sure you go out and grab the latest versions of these applications to make sure that you're protected as an end user, but also as development. If you're using Electron, make sure that you're just pulling the latest version and making sure everything's patched up and running as it should be. So hopefully this news helps you out. You find it interesting, and it helps build up what you're doing from an application security standpoint as a developer, as QA, but also as an end user, how you can be staying up to date on current things that are happening and understanding how much does this affect me and what do I need to do to make sure that I'm protected. So thanks for listening to the news, and we'll see you on the next broadcast. And that was our news segment for this episode. And now we're going to go ahead and switch over, and we're going to watch the demo of the application so we can actually see implementing two-factor authentication within a Gmail account. To see how simple it is to set this up, you just have to know what settings you need to approach and how to go about doing it. But once you do it, it's actually quite simple. So here's the demo to get you started on setting up two-factor authentication within Gmail. Here we're going to take a quick walkthrough of how to set up two-factor authentication in your Google account. The first thing you need to do is sign into your Google account, and then once you've done so, you need to go over to the little gear icon, and then you need to go down to Settings. Once you've clicked on Settings, you want to find the Accounts and Import tab, and on that, under Change Account Settings, look under Other Google Account Settings. This will pull up a new window where we're going to see a sign that says Sign In and Security. If we scroll that down, we can see there's a link for signing in to Google. Click the link for signing in to Google. Now notice over on the right-hand side, we have a section called Password and Sign-In Method. Here we're going to scroll down and find two-step verification. Go ahead and click that, and it'll give you a little notification alerting you to what two-step verification is good for. We just want to go ahead and say Get Started. Now at this point, it may ask you to re-authenticate, so log back in with your original password for your Google account. Once you've authenticated, it's going to ask you to set up your phone. This will pull the phone number that you set up when you initially configured your Google account. Here we're going to say we want to get text messages, and we're going to hit Next. Now it's sent a text message to my device. Now I need to go over and receive that text message and retrieve the value from it, and then I can input that into the code. So I'm going to input that now and then hit Next. Now it's turned on. It says it worked to turn on two-step verification. Do we want to enable this? Yes, we do. So we just go ahead and click Turn On. And now we have two-step verification turned on with SMS. So now every time you log in after you do username and password, it'll then send a code to your phone that you then enter as well to log into your account. There's also other options that you can select. As you can see here, there's an option for tired of typing verification codes, and you can add a Google prompt. So there's other ways that you can set up two-factor. The easiest is setting it up using the SMS message. So that's a quick example of how you can set up two-factor authentication on your Google account. So hopefully that quick demo provided you good information on how you can easily set up two-factor. I recommend setting up two-factor or multi-factor authentication on all applications that it's accessible for, whether you're using Google Authenticator, whether you use Authy, whether you use the SMS platform, whatever it is, set up that two-factor authentication. It's important to help protect your accounts in the event that somebody is able to get your username and password. Hopefully they won't be able to get that second factor and they'll be denied access into your account. So thanks for watching this episode, and keep an eye out for the next episode. We'll do work on getting out sharing links and that type of stuff so more people can get involved. But until the next episode, reach out again at DevelopSec on Twitter, or you can reach me at james@developsec.com. Thanks.